In the diagram, the circle with center A has radius 4, and A lies on the circle with which has center B and radius 3. The line passing through AB lies along the diameter of each circle and is perpendicular to MN at T. Also, MN is tangent to the larger circle, and MC and NC are each tangent to both the circles at points D, E, F, and G, as shown. Determine the area of MNC. Well, let's first draw in those tangent points, those lines, and let's proceed from there. So let's first see what it is exactly that they're asking. The area of MNC, that triangle, would be 1/2 base times height. Now, what's the base and what's the height? MNC. Oh, it's the entire triangle. Okay, I got it. I was thinking of something else for some reason. And then let's label this. So I'll call this, let's call this X, and let's call that X, MT and TN respectively. So MN would be that guy. And the height, of course, is all the way from C down to T. So MN, the way I've labeled it, is 2x, and CT, okay, CT, that is a little bit different. I think I can work with the information in the question. From T to A, that's a radii of 4. And then from A up to the top of the smaller circle, that's the full diameter of the smaller circle. And since the radius of the smaller circle is 3, that full diameter would be 6. So we got 4 and then 6. And then from that point to C, I don't know what that is, so I'm just going to call it Y. So it's 6 plus Y. Well, actually, hold on. No, wait. It's not 6 plus Y. It would be 4 plus 6 plus Y. So that's 10 plus Y. I got to make sure I do that right. How did I label this also? I labeled it, I think this was Y, and this is Z right here. So Y is actually from E to C. Z is the top and bottom. I'll just draw it in blue from there, from C to the top of that smaller circle. So that's 10 plus Z. So I got to first make sure that I set up the question properly. So that's really just going to be X times 10 plus Z. So then obviously I've got to figure out the numerical value of X and Z. Okay, so that's the first part. Now let's see, where are we going to get these values? Let me think about this. The first I think we could get is Y. The Y, I've labeled CE as Y, right? Now, Y is part of this triangle where this is a right angle. And the reason that's a right angle right there is because that is a tangent point. So triangle CEB, in that triangle, we've got a Pythagorean relationship. Y squared plus EB is the radius of the smaller circle, which is 3. So it's 3 squared, and then Z squared. So there we go. So that is the initial setup. So it would be 9 plus Y squared is Z squared, but unfortunately, I actually don't even have values of Y or Z, so we're going to have to come back to that one. I can use similar triangles with triangle CEB and triangle CDA. They're similar. And if I use similar triangles, then of course I can get a ratio of their sides. CEB and CDA. That should be pretty obvious that those are similar. So CB over CA would be the same as BE over AD. And therefore, that would be 3 plus Z over 6 plus Z is the same as 3 over 4. So if you cross multiply, you get 18 plus 3Z is 12 plus 4Z, and therefore Z is equal to 6. Okay, since Z is equal to 6, now we can do this. 9 plus Y squared. So therefore, Y squared would be 36 minus 9, which is 27. Hold on. Let me just do this, if I did this correctly here. Sorry about that. This is not Z squared. This is Z plus 3, because I got to add that. Sorry about that. It's a good thing I caught it. So it would be Z plus 3 squared So this actually is 6 plus 3 squared, like that. So therefore, that's 9 plus y squared is 6 plus 3 is 9, so 981. Aha. So y squared would be 81 minus 9, which is 72. And therefore, y would be the root of 72, which is 6 root 2. Okay, so maybe I got to do that carefully. Don't make any mistakes here. Okay, so far I've got z and I've got y. So I've got z here. So z is 6, so that's going to be 10 plus 6. Okay, so I'm 16x. I just have to find the value for x and I'm all done. Okay, great. So how do I find x? I think I use another similar triangle situation. So it'll be CEB this time. It's similar to triangle CTM. Yeah, CEB is similar to the big, sort of half of the big guy. And therefore, those relationship would give you BE over CE is equal to MT over CT. So therefore, that would be 3 over y is equal to x over 10 plus z. Well, z is 6, so that's going to be 3 times 16, which is 48, is equal to y is 6 root 2 x. So then if you divide this, this is going to be 8 over root 2. And then if you rationalize the denominator, it'll be 8 root 2 over 2, which is 4 root 2. All right, so there you go, 16 times 4 root 2. And that is 64 root 2. And that is the area of triangle MNC. Determine all triples x, y, z of real numbers that are solutions to the following system of equations. We are obviously going to have to use quite a bit of log rules. And one log rule that a lot of people don't remember is the following, that the log of a to the base b is the same as the log of a over the log of b. Now, if I don't put in a base, it's referred to as base 10. So I'm just going to assume that you know that. If there's no base written, it's base 10. Sometimes they do that. They don't put in the 10. So using that log law, a rule, whatever, we will try to modify these guys. So the first one is the log of z to the base 3. That would be the same as the log of z over the log of 3. Both to the base 10, but we don't write in the 10. We don't need to. And then if I put a 2 out front, obviously for both top and bottom, using log rules again, this one would become the log of z squared, because you can do that. And this one would become the log of 3 squared, which is 9. And therefore, if we move it back into that form, it would be the log of z squared to the base 9. So I hope you can see how that log rule really helped. And therefore, similarly, you can do the same thing to get that the log of y to the base 4 is the same as log of y squared to the base 16, just like I did here. And you can also get that the log of x to the base 5 is the same as the log of x squared to 25, using the same steps that I did there. So then we go back and we plug all that into those original 3 equations to modify them using these 3 findings. That this equals this and these 2 guys. So here we go. So the first one, which is going to be the log of 9 plus the log of y to the base 9 plus the log of z to the base 3, that equals, well, it equals 2, but we want to modify it. So I'm going to put the log of z to the base 3 is equal to this guy. So the log of x to the base 9 plus the log of y to the base 9 plus the log of z squared to the base 9. Okay, so that's really good, because now that we got it all in terms of one base, we can combine them using the log rule again. And that log rule is that if the same base, we can just multiply them x times y times z, and that equals 2. So you see how it all worked out really nicely. And now the basic log rule, 9 to the power of 2, would be x times y times z. So x times y times z is 81. So that's my first finding. And that's very good. We'll call that equation 1. Okay, so then now we turn our attention to that guy, equation 2. And that is the log of x to the base 16 plus the log of y to the base 4 plus the log of z to the base 16 is equal to, well, it's equal to 1, so we'll put that 1 way out there for now. But now, which one am I going to use? I'm going to use this guy right here, that little piece of information to plug in there. So that'll be the log, well, actually, I'll plug it in the middle here. The log of x to the base 16 plus, what is it, the log of y squared to the base 16 plus the log of z to the base 16. So then now they're all the same bases, so we can combine them. 16 is the base, x, y squared, z is all equal to 1. So therefore, 16 to the power of 1 is equal to x, y squared, z. And that we can call equation 2. And in a very similar way, we will work with that final one. That is the log of x to the base 5 plus the log of y to the base 25 plus the log of z to the base 25 is equal to 0 this time. And therefore, if I plug in this guy, that piece of information, it will be the log of x squared to the base 25 plus the log of y to the base 25 plus the log of z to the 25 base. Okay, so then that would give me, using log rules, the log to the base 25 of x squared times y times z is 0, and therefore 25 to the power of 0 is x squared yz, and therefore x squared yz is 1. And that is equation 3. Okay, so now we've got 3 equations, and we can now try to solve for x, y, and z. The first thing I will do is I'll multiply them all together. So equation 1 times equation 2 times equation 3, like that. If I do that, I will get x to the power of 4, y to the power of 4, and z to the power of 4 is equal to 16 times 81. And that, if I take the fourth root of both sides, I'll just get x, y, z is, well, 1296. The fourth root would be 6, actually. So there we go. And then now we are ready to figure out the individual values for x, y, and z. So if I take, I'll call this equation 4. If I take equation, where do I go from here? Sorry about this. I missed a squared here. There should have been a squared there. Sorry about that. It's a good thing I caught it. Otherwise, I would have messed up the entire question. You probably caught it and just wondered why I didn't put it in there. Okay, well, at least I caught it now. So then now, to figure out the individual values of x, y, and z, let's see how I can do that. To get x, I will take, let's see here. To get x, I will take equation 3 and divide by equation 4. So this one divided by this one. So that would basically be x squared yz divided by x, y, z. Those are equations. They're not numbers, by the way. And then that would basically just leave me with x. And then x squared yz was 1, and then x, y, z was 6. So x is 1 over 6. Okay, is that allowed? Are these integers? No, they're just real numbers. Ah, okay. They're not integers. I was wondering if I'd messed up again. Okay, so that's good. At least I'm on the right track. So I got x. So my x, y, z, I've got 1 over 6 for x. Okay, great. Okay, so for y, I will take equation 2 and divide by equation 4. So that would be x, y squared z divided by x, y, z. And that was going to be y. and that's going to be 1 over, hold on. Sorry, 16. This one is 16 over 6. So that's 8 over 3. So 8 over 3 goes there. And then one more that I've got to figure out z. Z, I will use equation 1 over equation 4. And that would give me x, y, z squared over x, y, z. And that's going to give me z is equal to 81 over 6. And let's see, 27 over 2. Yeah, 27 over 2. So there we go. So after all that, we got the triple. 1 over 6, 8 over 3, and 27 over 2. An ant walks along the x-axis by taking a sequence of steps of length 1. Some, all, or none of these steps are in the positive x direction. Some, all, or none of these steps are in the negative x direction. The ant begins at x equals 0, takes a total of n steps, and ends at x equals d. For each such sequence, let c be the number of times that the ant changes direction. Determine the number of different sequences of steps for which n equals 9 and d equals 5. Okay, so let's discuss this first before we jump right into the solution. So here is the graph, and let's just 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 in that direction. And in this particular case, n equals 9 and d equals 3. So what does that mean? D is, oh sorry, I jumped ahead. It's n equals 9 and d equals 5. Okay, n equals 9 and d equals 5. Okay, for part A I'm doing. Okay, so the d is referring to where it ends. So d equals 5, so this is where the ant ends. Where, regardless of whatever path the ant takes, it ends there. And then the number of steps is this. This is 9, so this is how many steps. And each step is of length 1. Okay. So the number of steps in the positive direction, since we're going right, I will call r. And the number of steps in the negative direction, since that would be going left, I will call L. So whenever we take a right step, we actually increase by plus 1. If we take a left step, we decrease by 1, so it would be negative 1. So we want to end up at 5, so the final result would be the number of times we go right, which would give us a plus 1. And then we have to add to that the number of times we go left, but that would give us a negative 1. And that, when we sum it all up, would equal 5. So this basically means that, this means what? This means that r minus L is equal to 5. And then we also know that the total number of steps is 9. So how many steps we took in the right direction, going in the positive direction, and how many steps we took going left, which is in the negative direction, that total is equal to 9. So that basically would be the setup of this question. And that seems pretty straightforward to solve for both r and L. So if I add these two, I will get 2r is 14, therefore r is equal to 7. And therefore, so I'll put a 7 there. And then L I can easily just get by plugging in there. And L looks to me like it's 2. Okay, that's pretty good. So the number of sequences, well, in total it looks like we have total 9 steps. Well, we knew that already. So from the 9 steps, I want to choose 7 to be the R's. So 9, choose 7. And then from the remaining 2 steps, I want to choose both of them to be the L's. And that basically would be the calculation. So 9 choose 7 is 9 times 8 over 2 times 1. And then 2 choose 2 is just 1. So that looks like 9 times 8 is 72. 72 divided by 2 is 36. So 36 is the answer to this question. So, for example, I just want to quickly, if we had 7 going 1, 2, 3, 4, 5, 6, 7. If we went 7 consecutively in the positive direction, and then we went back to -1, -1, we'd end up at this position, which is this position right here. That's just one of the 36 possible ways. I just wanted to illustrate that. Okay, moving on to part B. Suppose that n is 9, d is 3. Determine the number of sequence for which c is even. Okay, so we're going to pretty much parallel our explanation of part A, which is up here, but this time it's just slightly different, because now we're not being asked what is the total number. We're being asked determine the number of sequence for which c is even, and c is by definition the number of times that the ant changes direction, so that needs to be discussed a little bit. Okay, so here we go. First, let's figure out all this stuff here, all that stuff. So this time n equals 9 and d is equal to 3. So as before, r minus L is our final destination, which in this case is d is 3. Correct? Yeah. So that, and then the total number of steps, which is r plus L here, is 9. So if I add them, 2r would be 12, so therefore r is 6. So r this time is 6, and then L therefore would be 3. You can just get that by subbing r equals 6 into either of those. So the total number of sequences, as before, we have total number of 9 steps. From that, I'll choose 6 to be the r's, and then from the remaining 3, I choose all 3 to be the l's. So 9 choose 6, and you can calculate that as 84. But that's not really what we're asked. But I wanted to just do that just to kind of be complete. What we are asked is how many times is c even? Now, c is the number of times we change direction, right? By definition, c be the number of times that the ant changes direction. So let me just put that in there. C is the number of times the ant changes direction. Now, we want that to be even. So, for example, an even number is what? 0, 2, 4, 6, and so on, right? Now, 0, I don't think it's possible, because if we have 1, 2, 3, 4, 5, 6 times that we are going right, and then -1, -1, -1, we are going left 3 times, and we have to end up at 3. So there's no way that you could change direction 0 times. You would have to change direction at least once or twice or whatever in order to get back at 3. Yeah. So 0 is not possible. This one is not possible. So I'll cross that one out. 2 means you change direction twice. Okay. And I'm pretty sure that is possible. But I have to figure out, for this specific condition here, that r is 6 and L is 3. Let me see here. Let me just do a sample one. And let's see, I have r, L. Every time we switch from r to L, we're changing direction. So RL, 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 and then I've exhausted the L's. And how many R's are there? There's 6, right? So I've got to put 3 more R's. 1, 2, 3, 4, 5, 6. 1, 2, 3. Now, how many times did I change direction? 1, 2, 3, 4, 5, 6. Aha. And 6 is an even number. So that is the scenario. Yeah. For this particular situation, I don't think 2 and 4 are possible. Maybe for other, values of R and L and N and D and all that. So 6 is an even number. Okay, I got it. Okay, so there's a few scenarios here. The first one is we've got 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. If I put r's on either end, then in here I've got to put in the 3 l's. So from those 7 spots, I've got to choose 3 to be the l's. Got it? And then from the remaining 4 spots, you choose those 4s for the r's. And that doesn't really even need to be put in there, since 4 choose 4 is just 1, but I just put it in for the sake of completion. If we calculate this, 7 choose 3 is 35. Okay, so this is a scenario where the number of directions, C, would equal 6. And there's 35 possibilities, arrangements. The other one is if you have the l's at the either end. And then we got to fill in 1, 2, 3, 4, 5, 6, 7, right? And the same kind of story, that for in those 7, we've got to put the remaining 1 L, because there's 3 L's. And then from the remaining 6 spots, you put those 6 you choose those 6 for the R. And 7 choose 1 is just 7. So that 35 and that 7 combine to give a total of 42. And 42 is the answer to that question. Determine the number of pairs dn of integers for which n is between 1 and 2024 inclusive, d is greater than or equal to 0, for which c is even, for exactly half of the sequences of n steps that end at x equal d. Now for this question, we're pretty much going to do exactly what we already did. The only difference now is instead of numbers, we are just given d and n. We're given some sort of inequalities, but we have to work with d and n. So instead of going directly to d and n and making it look extremely abstract, we'll compare it to what we've already done, and that will allow us to follow it, perfectly, I hope. So let's just use what we did in part A. Exactly what we have in part A and part B, I kept it in the screen because I want you to see that it's really not anything different. So just like before, over here, we're going to have R minus L, and it's equal to D. And this time we don't know what D is. We're not given a number, so we'll just put R minus L is equal to D. And then R plus L, that is equal to N. And again, we don't know what n is, so we'll just put that in. We add these two equations. We get 2r is equal to d plus n, and therefore r is equal to d plus n over 2. Okay, so nothing fancy. R is equal to d plus n over 2. And then to calculate L, we just sub it back into either one of these, your choice. And when, like for example, L would be n minus r if we put it into here. And then that would be n minus d plus n over 2, and when you crunch out those numbers, you will get n minus d over 2. So that is my r, and that is my L. Okay, so that is basically the version without numbers. This was the version with numbers over here, where you had 5 and 9, but this is the version without numbers. Now the total sequences, well, we did that way over here, remember? So we take the total, which in this case is the total sequences. Let me write that down in total. Well, how did we calculate it before? The total sequences calculated before was basically we took the total, which was n, and from that you choose a certain number to be the r's. So to be the r's. And how many do you choose? Well, how many r's are there? There's d plus n over 2. So d plus n over 2. So n choose d plus n over 2 to be the r's. And then the other one, you don't really need to put in, because it's just going to be 1. So this is basically the total. But what they're saying in part C is that we want C to, let's see here, C is even for exactly half of the sequences of n steps. So what they're saying basically is that once you calculate the total number of steps, we want C to be half of that. So we want half of this n choose d plus n over 2. So that is the first part of this question. Now the second part of the question, we will mimic basically part B of this, which is what I did away all this stuff over here. If you recall, all the stuff here that I did, that is going to be basically what I would do over for this side, but more abstract. There's no numbers this time. We're just got to work with n's and d's. Very similar to before, we want C to be even. And there's two scenarios. The first is when you put the r's on opposite ends, and then we've got a whole bunch of these guys. We don't know how many. Just like how I did it in part B. So this time, before it was R we calculated as 6 and L was 3, that kind of thing, right? But we have no actual numbers this time. So we have to use L's and D's. So what was it again? We have it here. R was D plus N over 2, and L is N minus D over 2. So just like before, if we've lined up all the R's like that, we have one R at the very beginning and R at the very end, then how many do we have left? Well, we have the total number minus those two. So the total number is N. So N minus 2 are remaining in terms of the ones in the middle. From those, you have to choose a certain number of them to be the L's. And the number of L's is this one. So you have to choose N minus D over 2. So N minus 2, choose N minus D over 2. And this is for the L's. Got it? Very similar to what I did over here on the other side. And then the other scenario where you put the L's on either side, and then you have a whole bunch of letters in between. That's very similar. Again, that's N minus 2. And from those N minus 2, you want to choose a certain number to be the R's. Well, the R's are how many? Sorry, am I doing this right? No, I've got to, I'm going to choose the L's. I got to put the L's. Now, how many L's are there? Well, there's this many L's total, but I've already placed 2, so that minus 2 for the L's. You got it? So N minus 2, choose N minus D over 2, and then N minus 2, choose N minus D over 2 minus 2. And this guy and this guy, when you add them up, on this side I got 42, but on this side it's got to equal this. So if I were to put this all together, this N minus 2 N minus D over 2, that guy, plus N minus 2 N minus D over 2 minus 2, that whole thing equals this 1/2 N D plus N over 2. N choose D plus N over 2. Okay, so that's the setup. And then you have to simplify this. Simplifying, when you crunch out all these numbers at the very end, you'll get down to D squared is equal to N. And remember, N is between 2024 and 1. So since N is equal to a square, all the numbers between 1 and 2024 that are squares would qualify. So N would be equal to 1 squared, 2 squared, all the way up until 44 squared. Because 45 squared, I believe, is 2025, and that would fall outside of that range. So therefore, N looks like it has 44 values. But here's the thing. N equals 1 actually doesn't qualify. Because when N equals 1, C would be 1. And that's an odd number. So N equals 1 doesn't qualify. So N really is just 2 squared all the way till 44 squared. And therefore, the values of D would be 2, all the way to 44. So the pairs dn would be 2, 2 squared, 3, 3 squared, and so on, all the way up until 44 and 44 squared. Suppose that s and t are real numbers with s greater than 0, less than or equal to 1, t is greater than 0, less than or equal to 1. Points A, B, and C form ABC triangle. Points S and T lie on AC. Points P lies on AB, and point Q lies on BC. Neither P nor Q at a vertex of ABC. Line segments SP and TQ intersect at X. Partition ABC into 4 regions. For some such pairs ST of real numbers and points P and Q, the line segment SP and TQ in fact partition ABC into 4 regions of equal area. We call such a pair ST a balancing pair. Suppose that ST is a balancing pair with S equal to 1, and that the line segment SP and TQ partition ABC into 4 regions of equal area. Determine the coordinates of P. All right, so let's draw this all in. Okay, so let me attempt to draw it here. So we've got, that's our coordinate. Okay, so let us see here. We've got to make that, and let me label this. So this is A, right? This is B, or yeah, up here. And this is C. And then we've got this, we've got this S and T. S equals 1 in part A of this question. So C is 1, right? Let me put that in 1, 0. A is negative 1, 0. And B was 0, 4. So since S is equal to 1, that means S is right here, the same place as C. Correct? Because S is S0. So that's 1, 0. Okay. And then T is T, they don't tell us where it is. They just tell us it's minus T, and that T is between 0 and minus 1. So T is somewhere here. I don't know where it is. Let's just put T there. And there, its coordinates are minus T, 0. Okay. And then Q, I have no idea where Q is, so let's just put it up here. And then P, same thing. I have no clue where P is, so we're just going to put P somewhere. Okay, now I've got to draw those lines. Okay, so Q to T, and then the other one would be S to P, right? Now, I highly doubt that this is drawn to scale, but I'm just trying to illustrate it. Now, that big triangle ABC has been partitioned into 4 sections, as you can see, and they're saying that those 4 sections would be equal. Okay, all right. So the area triangle ABC, that area is 1/2 base times height. The base is obviously from A to C, which is 2, and the height is obviously from the origin to B, which would be 4. So that area is 4. Now, if the regions are all equal, and there's 4 of them, each region would have an area of 4 divided by 4, which is 1. Got it? Okay. So, which region do I want to concentrate on? Let's see here. Something that I could calculate fairly easily here. They want me to figure out the coordinates of P, right? So I've got to figure out the coordinates of P in this question. So the coordinates of P, well, whatever it is, I have no idea what it is actually. But that, since I have to figure that out, I'm going to concentrate on a triangle or region that has P in it. So let's concentrate on triangle APS. That triangle. That triangle actually is 2 regions. 2 regions. So that means it would have an area equal to 2, since each region has an area equal to 1. And did they give me any other information here? I'm trying to see here. P determine the coordinates of P. No, they don't give me anything about P. I guess I have to just manually do it. I have to figure this out. Okay. And the fact that this perhaps was not drawn to scale. But that's okay. I mean, the fact that it's not drawn to scale is not a big deal. Okay, let's do this here. So, well, I'm going to give it some letters here. I'm going to give the x, let's just call it AB. Yeah, that's fine. So the area of triangle APS would be 1/2 base times height. And the base goes all the way from A to S, right? So that's 2. And the height would be the y-coordinate of B, which is, sorry, the y-coordinate of P, which is B. So that looks like it's B. So since the area is 2, 2 is equal to B. Okay, so that's fairly good. Very quickly I got the y-coordinate of B. Now I got to figure out the x-coordinate, which I've labeled as A. And that probably is a little bit more trickier. I'm going to need to figure out the two lines here. Line AB, the equation, and then line, yeah, I think that would be sufficient. Yeah, find the equation line AB. Okay, well, you guys know how to figure out the equation of a line. I'll just do it really quickly. The slope would be 4 minus 0 over 0 minus 1. So that looks like 4. And then y is equal to mx plus b. So that means y is equal to 4x plus b. Sub in any of those points. If I put in 0, 4, that would mean that b is 4. So therefore, the equation of that line, AB, is y is equal to 4x plus 4. Okay, and since P is on that line, I substitute 2 for my y value to get the coordinates for x. So 2 is 4x plus 4. So that means 2 minus 4 minus 2 is equal to 4x. So therefore, x would be minus 2 over 4, which is negative 1/2. So negative 1/2 goes there. And there you go. I got the coordinates for P, which are negative 1/2 and 2. Prove that there exist real numbers d, e, f, g for which all balancing pairs st satisfy the equation of the form s squared plus t squared plus is equal to dst plus es plus ft plus g, and determine the values of d, e, f, and g. So we're basically going to follow a very similar pattern like we did up in part A. So it'd be helpful to have it on the same screen, but somehow I don't think I can. But you guys seen part A, so you should be able to follow part B. So as before, all the 4 regions are equal, and they have a area of 1. Okay, so we, again, if you very quickly draw that diagram again, it's a little bit different this time because s is not equal to 1. Before they had made that equal to 1. So this time t is wherever, but s is also not necessarily equal to 1. So this is still A, this is still B, and this is still C. And then again, P and Q somewhere. We don't know where they are. And then we again have to join them. And when we do, they would create 4 regions. And suppose we are supposed to draw it in a way that the 4 regions are equal. And perhaps, that's actually not so bad. It's certainly not drawn exactly to scale, but you guys get the point. Okay, so that's a pretty decent setup of the question. And then the intersection point is right there. I'll just call that X, which I think was what they did, right? Yeah, intersect at X. Okay, so that is exactly what I'm supposed to label it. Okay, so here we go. Here's the steps. We are going to look at triangles. So we're going to look at triangles SXT. SXT. We're going to look at triangles APS S. And we're going to look at triangles C, Q, and T. CQT. Okay, so I'll do, I'm going to go through the steps. I'm going to let you guys do some of the work at least, but because a lot of it is similar. So let's start with SXT. The area of that, since it's just one region, it would be 1, and the area is 1/2 base times height. The base would be, well, I got to label this. S was S0, right? And T is minus T0, like that. So the base would be going from S to T, so it would be S plus T. Yeah, and the height, well, we don't know the heights, so I have to give them heights. Yeah, I've got to give them heights. So this one I'll call H, this one I'll call P, and this one I'll call Q. These are the heights. So for this one, it would be H. So therefore, H looks like it's 2 over S plus T. Yeah. And very similarly, when we do it for these triangles, we will get P is equal to 4 over S plus 1, because this is negative 1, 0, and this is 1, 0, C and A. And then, of course, APS is 2 regions. That's why the area is 2. And then for CQT, it'll be very similar. We'll get that height equal to 4 over T plus 1. Okay, so that's the initial setup. Okay, so now let's just continue with one of these. Let's say we have let's work with triangle APS. So in triangle APS, we figured out that we had 2 is the area, and that's 1/2 base times height, which is S plus 1 over, well, we called it P, right? Yeah, for the height. That's how we got that P was equal to 4 over S plus 1. Now in APS, that basically means that this is the height of triangle APS. So that is basically the y coordinate of point P. So that 4 over S plus 1 is actually goes here, 4 over S plus 1, like that. It's the y coordinate of P. Now to get the S coordinate, we'd have to put it on the line AB, just how we did previously. In line AB, if you recall, we did the equation, it was 4x plus 4. So to get the x coordinate of P, we'd put the y coordinate into here. So we get solve for x. And when you do solve for x, you get x equal to minus S over S plus 1. So this is minus S over S plus 1. Got it? So that's how you get the coordinate of P. And in a very similar way, you would get the coordinate of Q. And I'll let you do that exactly the same way. Q is here, so that's the y coordinate of Q. So that's 4 over T plus 1. So 4 over T plus 1. And then you'd have to figure out the equation of the line BC. And you can do that fairly easily. And then once you get that equation, you'd sub in the y value to get the x value. And when you do, you'll get T over T plus 1. Okay. And now what? Now you have to do is you have to concentrate on trying to get the coordinates of x. X is the guy in the middle here. So this guy right here. Now how do we get the coordinates of x? Well, the coordinates of x are obviously the intersection point of line PS and QT, correct? So wherever they intersect. So using our points Q and T, you can get the line QT. And using our points P and P and what? P and S. Yeah, you'd get the line PS. Okay. And when you do that, you'd get the following lines. PS, I'll let you guys do that. I'm sure you can figure out the equation of a line. PS would be y is equal to minus 4 over s squared plus 2s times x minus s. And the equation QT, that is y is equal to 4 over t squared plus 2t times x plus t. So those are the two equations. So then when we set them equal to each other, that's where we get the intersection point, which is x. So when we set them equal to each other and solve, set this equal to this, and solve, we will get x equal to st squared minus s squared t all over t squared plus 2t plus s squared plus 2s. Okay, and then sub back into either one of these to get y, and when we get y is equal to 4 times s plus t all over t squared plus 2t plus s squared plus 2s. Okay, so what are we trying to figure out? We are trying to figure out this kind of equation here, and then trying to figure out the integer values. Okay, well, how do we get that equation? Well, recall that at the very beginning in triangle SXT, I had denoted the height as h. And the height is basically the y-coordinate of x. So I know that's a very confusing statement, but it's the y-coordinate of this point that I have called x. Okay? That is what h is. So 2 over s plus t. 2 over s plus t is the y-coordinate of that point x. Now the y-coordinate is right here. Okay? So 2 over s plus t is the equivalent of 4 times s plus t all over t squared plus 2t plus s squared plus 2s. Okay, so now I believe that if you simplified this, we would get this equation that they are trying us to get. And when you do simplifying that thing, cross multiply, collect like terms, blah blah blah, you would eventually get s squared plus t squared is equal to minus 4st plus 2s plus 2t. And let's see if it fits. First of all, let me write this down there and compare. So that one was s squared plus t squared is equal to, it was dst plus es plus ft plus g. Okay, so comparing these two, it looks to me like d is negative 4, e is equal to 2, f is equal to 2, and there is no actual g, so g looks like it's 0. So d is negative 4, e is 2, f is 2, and g is 0, and I think that's what they wanted. They want us to figure out the values of d, e, f, and g. So there we go. We got them.